So a little about me before we start. I spent 10 years at Volition working on the 4 Saints Row titles. I worked at Firaxis for 10 years working on the XCOM titles and Marvel's Midnight Suns. And now I am a principal engineer at Midsummer Studios, a small local startup. XCOM was made in Unreal 3. Marvel's Midnight Suns was in Unreal 4, and at Midsummer we're working with Unreal 5. I have contributed about 15 pull requests now to the engine. One of those is the for each node that works on the tmap container and the tset container that were contributed to 5.6. I also use the engine at home for personal projects. I'm also the Baltimore lead of the Baltimore Chapter of the Unreal Communities program. And then here is my contact information. The slides will be available at the end if you need them. So this presentation is based on a tutorial that I wrote back in 2021 for gamedev.net here, and then the GitHub that I made to support that tutorial. But this is going to be a little higher level than those. So those are still going to be great resources to use if you're interested after this talk is done. So what are we going to talk about? We're going to set a little bit of expectations first about what I'm going to present. There's a lot of information that could be here, so we're going to kind of narrow that down just a little bit. I'll talk about why these are even worth considering. And I'll cover some of the basic setup for what you need to do before you can even start writing any of this stuff, because there's always a little bit of setup first. There'll be some really basic functions that you'll need before we get too far into the talk, so I'll talk about those a little bit. The main portion of the talk is going to be my process. It's going to try to give an example of how to build these really fast and in an order that will help you validate kind of what you're building as you're building it. I'll revisit this question as to why, so that now once we know what we're kind of building, I'll give a better example of a thing and why you would do this sort of thing. The next best part of the talk is going to be these tips, tricks, and gotchas. I've been doing this, they're weird to do. And so there's some real quick tricks that can help you not get hung up for too long when you're trying to make them. And then I'll have a couple of slides about some of the more uncommon functions that you can call that can really give your nodes some really interesting functionality, but they're not necessarily needed all the time. And then I'll have some time for questions. I've got a bunch of links at the end, some appendices that you can look at with some code samples if you take a look at this deck on your own time, but they aren't particularly interesting or helpful to blow up on the projector. So we're going to set some expectations here because, like I said, there's a lot to talk about. So we're going to talk about Unreal 5 specifically. This is true if you're working in Unreal 4. There are going to be some differences. And apologies to anybody watching video and being in Unreal 6, because I don't know what they're going to do. I'm going to try to make this on an API dump. It's really easy to do a talk like this and just be like, here's a function, here's a bunch of parameters, here's a function, here's a bunch of parameters. You have the code, it's there. There's other websites and some other tutorials that list a lot of those things and describe them a lot better. And it's not the best use of this time. There's also a bigger world beyond blueprints that are the editor nodes. The material editor, the reference viewer. There's a lot of other tools that use the same underlying technology. Some of this helps doing those things, and some of it doesn't. Some of it's very specific to blueprints, some of it's not. But we're going to be talking very specifically about the things for Blueprint that may or may not be applicable to those other graph editors. This is going to look a lot like trying to write Blueprint in C++, which sounds crazy. But there'll be analogs to what you do in Blueprint in the actual visual graph editor and what you're doing in the C++. You're basically making Blueprint macros in C++. So everything that you would do in a macro, you would do here in C++. There's also a whole nother set of talks that could be covered using Slate, if you know what that is, which is the editor UI framework, as well as this really weird sounding structure here, these node functors, that are another way to do Blueprint nodes that are related to what I'll be talking about, but are much more complicated, and that I will be kind of glossing over. This is going to be kind of a technical talk, so if I raise hands, who's here as like a programmer? Cool. Artists? Cool. Awesome. What's that?
Tech art.
Tech art. Okay. Yeah. So I'm like, this is going to be kind of technical, but I'm hoping that everybody gets something out of this, even if it's like you take the link to this talk back to people on your team, and they can do this kind of stuff for you to help you with your own tool, and maybe get you an idea of, man, it'd be really cool if this thing I'm doing in Blueprint worked like this. Maybe they can do that for you. So, like I said, these are complicated. Why would you even spend the time to do these? So you can do Blueprint callable functions in the engine. They do a great job of exposing these things for you, but there are some limitations to them. The markup here can do a lot of really cool things. This determines output type, can change the type of outputs for you. You can do this weird scripting kind of thing called custom funcs, and it'll do a lot more of like dynamic type things for you. But there's a lot of limitations on these still. You can't have multiple wildcards. You can't do multiple outputs from a single node like you would if you have a for each node of arrays that hits, those outputs happen multiple times. You can't do that with just a Blueprint callable function. So some of the new tools that you get when you start doing these things in Blueprint would be dynamic pins. So this is the spawn actor Blueprint node that is available in the engine, and as you select the class, it adds all sorts of parameters from the expose on spawn markup to just wire them in as pins. So as you select a different class, all of those pins update dynamically to be whatever is correct for the class that you are spawning. You can do dependent type. So this is the for each for the T map, and as you plug in a map of whatever kind of type to type, the output pins for key and value change to the right types. You can add a details panel, so you would see this in the switch for the gameplay tag, so you can just add whatever switch cases that you want. You could do custom async nodes, so this is one of mine that doesn't use the async support of the engine, but gets you the same, very similar functionality. The built-in one doesn't let you do different parameters, but you could build that into yours if you need it. You can also take a lot more control over what things can be connected to each other, or where you can put your nodes. Similar to like protected functions not being able to be called in certain places, you can limit your nodes to the event graph or the function graphs, and do a lot of interesting things there. So you'll have to do a couple of quick things before you make any of these Blueprint nodes. You'll have to make an uncooked only module. You're probably familiar with the runtime module. If you're doing C++, that's the one that all your game code generally goes into. It has some Because you need these in a standalone build, this would be running your editor with the -game command line parameter. It can't do editor things, but it can load uncooked modules because the standalone is going to compile your blueprints on the road. So since we need them in standalone, we can't put them in an editor module. The blueprint graph and the editor graph are really important dependencies that you'll end up using a lot of functionality out of. And those are reasons why we can't put them into a runtime module. When I've just come to the point where if I make new plugins and games, I just make runtime, uncooked, and editor modules just kind of from the start, just so that I have a place to put these kinds of tools when I need them, and I don't have to like backtrack and make these modules later. There's really no downside to having these empty modules, so it's not a big deal to make them, but it's also not a big deal to have them later if you don't have them yet. And then before we get started, you should be aware of, so as programmers, you'll be familiar with the different times, like compile time and runtime, that are available for game development. And so there are even more that you have to deal with now. So at the very bottom is the native in C++, you're very familiar with. This is where everything ends up funneling eventually. The compiled blueprints run on a specialized virtual machine. So all the blueprints end up compiling down to this blueprint bytecode that gets run. And then that bytecode is caused by these generated graphs. And these generated graphs are basically copies of your blueprint that get compiled. A bunch of stuff happens to them to replace macros, to replace these custom blueprint nodes with other nodes that eventually get turned into this VM bytecode and run and call all the C++. At the very top is the editor graph, which doesn't read too well here. That says editor graph there in blue. This is the graph that you are actually editing. Almost all, except for one function that you use that we'll be talking about, happens in the editor graph, and then it's all copied and turned into this generated graph, and then that generated graph is compiled into the virtual machine bytecode. So there's a lot of different times here: compile time of your C, runtime of your game, runtime of your editor, and compile time of the blueprints. And so depending on what you're doing and what you're trying to do, those are all going to be important distinctions that you may have to take into consideration when you're writing new blueprints, or blueprint nodes, excuse me. So we'll start with some of the really basic functions that you'll end up using. Allocate default pins. This is where you're going to allocate, where you're going to create all of the inputs and outputs that are shown on your node. Expand node. This is where you're going to basically take all of the things that they've plugged into your node, and you're going to, in turn, spawn other blueprint nodes. These ones are the ones that will actually generate the VM bytecode, because yours is just going to get replaced. It's basically getting replaced by everything you're making in this expand node function. This expand node function, this is the one function I was talking about that is actually happening in that generated graph instead of in the editor graph. This is a weird kind of function. You'll always override this to return true because your node is never going to be in the final output for what we're talking about here. So you'll just override this to return true and kind of ignore that all the time, and just kind of ignore that all the time. Get menu actions is a function that you'll have to override with some very boilerplate code, because this is what's going to have it show up in the right-click menu when you're trying to place down blueprint nodes onto the graph. I have a version of this in the appendices as a quick boilerplate. I've put it into a function that I reuse all over the place because you're gonna have kind of one node, and then you just need one little thing to get into that menu, and you're done. But you can do a lot more complicated things in here if you want. For example, when you call functions, every function call is the same Blueprint node, but they just use this get menu actions to populate the UI with a million different ones based on the reflection that the engine has about all of the Blueprint Callable functions. And then there's a bunch of display customization functions that all basically have an analog to what you would do with the Blueprint Callable functions. You can you can set the category, you can change the display name, the tooltip, and do a lot of and do everything that you would do with markup. You still have a way to do that with the custom node. So now my process, and we're going to be using the for each node that I wrote because it's a great example of why you would do Blueprint nodes at all in C++. It has multiple wildcards. The map requires 2 wildcards, the key and the value. Unfortunately, Blueprint macros can only support 1. So you're already kind of in a bad place there. Obviously, Blueprint macros can support 1, which is why the for each node for arrays is a Blueprint macro. But you can't do 2. It's got a bunch of dynamic pins. You can get those with the custom func feature. I mean, the maps have plenty of C++ calls as U functions. And so you could do that, but then you run into the problem of repeat execs. This loop body execution pin is going to run over and over and over again for every element of that map. And you can't do that with a U function. So the first thing is just kind of setting up a quick framework of code for your Blueprint node, which is creating some new files, bracketing in with this lock text namespace macro that if you haven't run into, it's part of the localization process. It's a little weird that for the editor we do localization stuff, but it's part of how those nodes get written. So you'll see that a lot, especially if you go look in the code. So it's worth having there. It also makes it really easy to copy paste these nodes. Copy paste this code from one Blueprint node that you've written into another one because this namespace will change for each file. And you won't get conflicts in names. Next is the class declaration. These are going to be the same as every other class that you're making in C++. They're just in a slightly different way. We're going to be talking about this UK2 node as a base class because that's the lowest level one. That's the first one that you would encounter. There's a bunch of other ones that you can. I'll talk about at least one of them a little later on. But for now, we'll just stick with the very, very basic one. You want to do some of those basic overrides that I just talked about. The is safe to ignore is true, providing an empty body for these other ones. You'll want to do whatever visual elements and the get menu action override that you want in order so that you can place it onto the Blueprint graph. And after you've done all of this, you get a node that would look like this, which, I mean, you can place it in the Blueprint graph, but that's not super useful, is it? But we're getting there. So next is making all of the pins. So the pins are what the engine calls all of the inputs and outputs to these nodes. They're all the colored shapes, both the white ones as well as the colored ones. Some of them have a shape to them. I start with the names as pins, as static F names in the node. Epic puts them in unnamed namespaces in in the CPP file. You can do, as long as you have them available, it doesn't matter too much where they are. I then add a bunch of accessors for them so that they're really easy to get at and I don't have to reuse that name in too many places. And then we're gonna implement them in allocate default pins, where we're gonna call a create pin function. And for this create pin function, we are gonna give it a few pieces of information. The direction, so inputs are on the left of the pin, outputs are on the right of the pin. A category, so this is gonna be, is it a name, is it a string, is it an object, is it a structure? And then we're category, and then we're gonna give it a name, and this would be the F names that we gave it, that we declared earlier. There are a whole lot of other configurations that you can pass into the create pin function, but they're just as easy to do after you create the pin, like in this example that I have here, where you can change the name of the pin, you can give it a tooltip, you can set all sorts of flags on it, whether or not it's a const or reference, whether it's what it looks like. You can pass those into create pin, or you can do them afterwards. It's equivalent. It's whatever is easiest and makes the most sense for you. And so after you've done all that, our node's gonna look something like this, which, I mean, that looks like a node that you could use, which is great. And so we've only implemented we've basically implemented like one function, this allocate default pin, and we've got something that looks like a node that we could use. Next is doing all the kind of UX portions of it. So we're going to do things that are dynamic. So in this case, using, when the pin is connected, changing the type of the other two output pins. We can do, there's customization that you can do based on, you can change the title based on that hookup. You can change the other pins that are on that node based on what's passed in. Like in the spawn actor case. This is also when you would handle blueprint save load. So when you save your blueprint and load your blueprint, you want all these connections to be the same and have it look the same as when you saved it. There can be some tricks here, or some gotchas here that I'll talk about later, but for the most part, but this is when I would solve those. This is when I solve those problems. Ditto with copy paste. If you're moving, you've got the node, you should be able to copy paste it and have it look roughly the same, depending on what you copy paste. I also add error handling at this time. And then this is going to be a lot of very node specific work. So depending on what the node is supposed to do, you may have very specific behavior that you want from it. And this is when it's good to do. Try working with it a little. It's not going to do anything. You're not going to be able to like run your game and have it do stuff in there. But the workflow of putting it into your blueprints, wiring it up to things, and seeing if that makes things better or what it should do in response to the user could all work right now before it does anything in your game. So this is a great time to do that before you get too bogged down in what's going to be kind of harder processes. Or not harder, more complicated processes. Yeah, like I said, use it. Next is the functionality. So this is where we're going to be implementing the expand node function. And this is going to be a lot of calling this function here, which is spawn intermediate node. Compiler context is a value that's passed into the expand node function. And you're going to call this function, you're going to do the initialization process for whatever node you spawn. And unfortunately, that can be that's very different for every single node. I'll have an example for one of them in just a bit. And then you will manually call their version of allocate default pins. And so that'll turn your initialization step into all of the pins on either side. You'll get all of the pins, and you'll connect all the pins using one of these two functions here, make link to, try create connection. And this will, this is basically like you dragging pins between each other on the blueprint graph. There's some minor differences. You can always call try create connection. Sometimes make link to is just a little easier to do. It just kind of depends on how dynamic the node that you're using is. And then you would move or copy your node, your pins. So you've got a bunch of connections to your node, and you've spawned some nodes, and now you're going to move them from your connections to these ones that you've spawned. The engine provides both a move and a copy. If you want them to be if the pins that they've connected are meant to connect to multiple things inside of your node, then you have copy. Otherwise, move empties out your pin connections. So an example. So then you're just going to have to figure out a way that you want to organize it. One way is to call the super, do all the error handling, spawn all the node, like very batched. Do everything, do everything, do everything, do everything. You can also kind of interleave it so that you're doing you spawn a node, get its pins, connect things up, and then spawn the next one connected to the thing that you just made, and then spawn the next one connected to the thing you just made. I tend to use the interleave one. It just kind of flows a little bit better, but you want to find something that works for how you write code. So next, we'll give a kind of example. So we're going to use this call function node as an example. It's the one that you'll probably use the most often. And this lets you basically call a function in C++ that would have your functionality. So we're going to call that spawn intermediate node function that I mentioned earlier. We're going to do this set external member on the function reference. This is its version of initialization. It's a little weird, but we're telling it the name of a function to call and the class that function is in. There's this handy macro, so that if that function disappears, that macro will generate a compile error. And then once it's all configured, we call allocate default pins. And then when we're ready for the nodes, we can call find pin on that call function node that we made. Unfortunately, because of how generic call function is, there's nothing better that you can do than just kind of putting a bunch of string literals in there for each of the parameters that you want. So you got to be careful about that, but it's pretty easy to like copy paste that text from the function you're calling to here. And then other nodes similar to the ones that you hopefully created for your node will have functions like this get return value pin that will return pins as well. Lastly is testing. You want to test your blueprint compile and your runtime. And this sounds silly to call out, but it's so important to do. You want to make sure all this is working before you're passing it off to your team, because now is going to be way easier to fix this than after they're using it. And that's all great, but you're probably still going, that's a lot of work for a for-loop node. So here we have an example of something that comes up tons in games, right? You want a modal dialog box that pops up, get some input from the user, and you do something with it. And so here in this example, we've got spawning a widget, initializing the widget, assigning to some delegates, and then adding it to the viewport so it's visible by the player. And this is fine. Like you can, but it can be a little brittle. You don't want this is 5 nodes in your blueprint already. If somebody else is doing it, did they forget one of them? Did they not hook up to something? Did they not initialize it correctly? Are they adding it to the viewport correctly? Unreal has like multiple ways to do everything. So did they do it the way that it's supposed to be done for this? A function is a perfectly fine way to do this, but then you need a function for every different dialog box you want to pop up. And that can be a headache and is not necessarily as helpful as you might hope. So with these custom nodes, you can turn this. Oh, sorry. We got our, this is just going through everything. So you can see The init is adding parameters, the expose on the create had some parameters, we got some delegates that we're binding to, adding to the viewport. And so instead, you could turn it into this. All five of those nodes are now being done by this one node here. We've still got the class selection and the expose on spawn parameters that the create widget node had. We've just built in the init function. It could even be optional. So if it has an init function, it shows the parameters. If it doesn't, then they're omitted and it doesn't call that function. It's got all of the delegates already pre-bound. You don't have to know what delegates to bind to anymore. They're just right there on the node. And you can just drop this now anywhere. So those are cool. And we've got one of these in I've got one of these in my project at home. I've built one of these for our UI stack at Midsummer. So some tips, tricks, and gotchas. Immediately, the thing to be aware of is that Blueprint macros. They're in Blueprint. They're not in C++, so you'll lose a lot of them. It's like this is valid, and the array for each. It kind of sucks. It's there might be a way to do it, but it's probably way too complicated to be worth it. Again, to be aware of those Blueprint, those module problems of times, you're gonna want, your module is gonna have to be in, or your Blueprint node is gonna have to be in one of these weird uncooked only modules, but you wanna call functions that are in your runtime module. So you're not gonna add functions for your game into your Blueprint node. It's gonna be calling functions, probably in a Blueprint library, but it could be on any other object that you're able to get access to. Maybe even private functions, and then there's this handy flag, Blueprint internal use only, that you can put on functions so that in that menu, you only see your custom node. You don't see these utility functions that you've made to support your node. And then again, to remember all these multiple times that are going to be happening: the C++ compile time, the editor runtime, Blueprint compile time, and the game runtime. There's different things that you can do with these different times. A lot of people get a little bit confused here because what they want to do is make the node dynamic based on the value of connections in the Blueprint graph. And that's not really how Blueprint works. In the Blueprint graph, those variables and stuff that you have are promises. Think of them like promises. They're a promise of a value of some type, but they're not an actual value. So you can use the type to do things, but you can't necessarily, even if it's got a value on it, you can't necessarily assume that that value is what's going to be used by the Blueprint node at runtime. And then when expand node is called, we're in a duplicate of your graph. So if you've kept variables or you're caching things on your Blueprint node, those may not be the same value that your node has when expand node is called. It's a weird thing that can get you. The good news is if you make your things view properties and add view property to them as the macro, that copy process will copy that information over. It will also can help with some of the save load issues as well. Next is some prototyping. So how do you even figure out what you want to build? We're making Blueprint in C++, so you can use Blueprint to prototype these things. You can call function, you can make Blueprint functions that are kind of similar to what you're building, but not as useful because they won't be as dynamic. But they're good first steps, as well as making your own macros or just making stuff on the event graph. And so, again, the for loop node that I added, here is a version of it prototyped in a Blueprint. The comment makes a really good way to bracket the space of what would be inside the node versus outside the node. The reroute pins on the left and right make a really good way, make it really easy to be like, here's one of the pins I'm gonna need, and then visualizing it in your head of what parts of the outside is connected to the inside. Again, you want to avoid macros. That's why this isn't using the TRA for each, is because it won't be available in C++ when you make it. And then the purpose for this is, for the purpose of prototyping, if you're using that internal use only flag, you can exclude that so that you can drop it on your blueprint for prototyping. And eventually, you'll become comfortable enough with this where you probably won't need to do this. I don't do this for new nodes that I make. I did this for a lot of the initial ones to help out. But eventually you'll move past this, just like a lot of other as you gain experience with it. The next tip that people love and are surprised by is if you've got something like this and your node's just not working during the testing phase, there is, if you go to File, Developer, Save Intermediate Build Products, when you compile, it's going to create a whole nother event graph for you that is going to look like that, which you can't read, and even in the editor, you can't read this. You'll have to move the nodes around a bit, but it's got that comment block there for the things that were on the event graph initially, and then you can kind of manually massage this or use a node layout tool to help you move these things around, and it will and it's basically showing you all of the nodes and how they're connected based on what you wrote in expand mode. So I wish I had known about this tool, about this flag way earlier when I was working on these things. A lot of the quick tips that I've come, take advantage of the available source code. The engine is source available. Anybody can get access to their GitHub. Even on the launcher build, you have access to the source. Go look at it. If you're trying to make a node that does something and you can be like, hey, that node does what I want, you can find that node in the engine and figure out what part of it is doing that and be like, I'm gonna steal that. That's how I made most of the things to start with. The CDOs, so the class default objects, this is when you're dealing with pins of object types and structures. You might not have the variable data, you might not have an actual value, but for both of those you have a class default object that can kind of act as a value. So if you need things that are based on the class, so if you've got a pin coming in and the variable is actor, you can get at the actor CDO and use information from that CDO to do dynamic things, especially if you've got a lot of one-to-one relationships of when it's this type, it's always doing this thing. This is how the expose on spawn is able to do a lot of things. You can hard code values. If a function takes a parameter, you don't have to make a pin for that. You can fill in parts of the pin. It's got a default value, a default object, and a default string, or default text, excuse me, that you can set directly inside of your code. So if you're calling a function that takes a Boolean, you don't have to put that pin on your node. You could just get that pin during expand node, set the text to 0 or 1, and then it's hard-coded for every call of your custom node. The default value is a string, so when you're doing anything other than strings, it's a little weird to convert numbers and enumerations and things that aren't strings into strings in order to call that. But that's just something you gotta work on. U functions. So like I said, since you can't really call any functions on your node to do game work, putting U functions on the Blueprint nodes isn't super helpful. But the one case where it is to act as delegate signatures. So there's the red box. It's a way to do callbacks. Those all have signatures of parameters of inputs and outputs that you have to get to match right. And one of those things that it takes is a U object that comes out of these functions. And so U functions are really helpful in your blueprint, in the blueprint nodes for doing that sort of thing. You want to make sure that all of your pins are doing something during the span node. It's really easy to forget to connect one of your pins to one of the spawn pins. IDEs have some pretty good coloring nowadays to see that you're using a local variable that you've made. You can also just do quick finding files to see if it's showing up anywhere in your function body. Don't ignore your debugger and output windows. Being able to step through your expand node as it does things and watching the output window or looking at the output window when you compile your blueprint can give you a lot of really helpful information for why your blueprint node may or may not be compiling correctly or running correctly. You still want to take advantage of U-function markup, so all of those blueprint internal functions that you write, you can still do the markup so that the call function node does a bunch of the work that you want it to do instead of you having to do it yourself. Things like the expand bool, so that you don't have to put a branch in there. You can just have your function return a bool, use the markup, and now it has two exec lines that you can connect up to instead of having to do that branch yourself. A bunch of quick functions to hit. There's a bunch of a couple of functions that you can use to respond to things getting connected and values being changed. And this is where that dynamism comes in. This is how you respond to those things. You want to be careful in that first one, which is why I call it out. There's two different virtual functions, one called notify pin and one that's just pin list changed. You want to override the notify. The other one is only virtual for historical reasons. Post reconstruct node, if you're doing any of the dynamic stuff, this is a good one, an important one to override to reestablish what some of those dynamic things are so you don't have to save them, and you can just, and this will get called when things get pasted or when they're loaded from, when they're loaded up. This is the function that you could override to return true to let you do default property, to do the details panel, so that you could not have it as a pin and just have it in the details panel instead if it doesn't need to take runtime inputs. Once you override this as true, you could just add U properties that are edit default only to your node, and when your node is selected, they'll show up in the details panel. Pretty straightforward and pretty cool. There's a whole lot more display customization options for like the color, the icon, corner icons. There's a lot. And then this is another one. So I talked about, we were driving from the UK2 node. There's this one called create object from class. This is the one that kind of, this one is a base class for doing stuff like the actor spawn. So if you derive from this one, it'll do like a lot of that spawn and dynamic pin stuff for you, so you don't have to worry about it. But it has its own suite of virtual functions to override, so that you can do your own, create your own pins when the class changes, so that you can identify pins to not get deleted when the class changes. And then there's a lot of, so these are some advanced ones that are really interesting to use, but are pretty niche use cases, but they're worth knowing. You can do you can get your right-click menu on your node to do stuff. You can prevent it from being put into certain kinds of graphs. You can prevent pins from connecting to each other in certain ways if you don't want them to. If you double-click on them, you can get them to take you places like code or other blueprints, which like when you have your object, when you have those like class selectors, doing that is so awesome. You can make it so that if your node is meant to be latent and should only be on the event graph, you can make sure that it gets put into a macro. It makes that macro latent as well, which is what the default a lot of other engine ones do. You can make it look like a custom event, show up in the tree view of all of the event graph. And you can do some text caching, depending on how dynamic your node title is. Building those strings can be really expensive. And so they've got this little structure that tracks how things have changed, what the value is, to know if you need to redo and recalculate what that text is. So here is the QR code for this presentation if you want it. And then we still got time. Excellent. Anybody has questions?
Yeah, so this is a little off topic, but a lot of games recently with Unreal have been shipping without being optimized well. Do you blame the engine or the dev?
Both. I mean, the engine just provides a lot of tools, and if the devs use those tools wrong or they don't spend the time to do that, I mean, the engine could be super optimized and then you can still write super bad code or blueprint. So, yeah.
The engine out of the box is super optimized. It's like when you do nothing, the blank project it'll run great. But there's other devs that I think, especially
we can talk about that after. It's definitely way off topic for this presentation.
There's a lot of theme online with optimization on Unreal. It's kind of wild. I don't know how the rep started, but it's like back in the Unity days where a lot of like bad stuff. It's like made with Unity splash screens, the mark of the devil.
Yeah.
How different is this if you're working with other graphs like material editor, for instance?
I am not entirely sure, but a lot of there is the K2 node derives from an editor graph node. There might be a material one that is equivalent to the K2 node. I haven't done that, so I can't speak exactly, but it's all still part of the same family. A lot of these functions are still part of the general graph thing. So some of these, I'm not sure which ones exactly, but it's they're all kind of in the same family in there. I'm not entirely sure exactly how much is overlaps. I haven't done it.
Obviously the end point is going to be
Very different.
shaders, right?
Yeah.
Does it go through that same copy and expansion process?
I don't think so because I think that is a very because the output is very different. So I don't think so, but don't quote me.
Well, this is new to me. I guess I'll
Yeah.
find out eventually.
But I mean, yeah, knowing that this stuff is possible with blueprints, I mean, it can make it easier to jump into those kind of things for sure. Yeah.
What are the most common custom blueprints you've added to your projects?
That's a great question. So the dialog box one is a big one. They tend to be kind of system specific because what'll happen is you'll write because I'm a C++ guy, so I tend to write systems in C++, and the way that they work and best work with C++ isn't necessarily directly accessible to Blueprint. I like writing a lot of template functions because they make the C++ better and more type safe, but you can't expose those to Blueprint. So a lot of the time, I'll do a lot of the factory kind of functions where it's Where normally you would do things kind of like that widget where it'd be like, okay, I'm gonna call this function to allocate the thing, then I need to initialize the thing, then I need to give it to the system that wants to do things with those. Those are pretty common for me to do things like that. Or to do things where I want the node to be dynamic, where it's like, okay, I'm passing in this object type, which is an object type specific to our project, and I know that if I call this function, the output is always related to the input in some way, and I don't want to have to manually cast it because the person writing the blueprint shouldn't have to know that that type relationship exists. So do some things like that. The for each node was one that I wrote way back on Midnight Suns because we were writing Blueprint, and it's like, how do you not have a way to iterate all the elements of this container? And so there were lots of examples of code online at the time of like, oh, here's the snippet that you can do to get all the keys and then iterate all the keys and get the value for each key. And you would have to do that for every kind of mapping that you wanted to have. And it was like, how is that not a thing? So I wrote that for at home initially, brought that into work for Midnight Suns. I had it in my own plugin library for a long time while it was an outstanding pull request. And then I was really happy to get traction from Epic and the way their pull request stuff works, so that that one, as well as the pull request for the T-set, which I didn't do initially, but helped with the pull request for that one, and they helped solve an issue with my own for loop one, with my own map one, and so those were integrated into the 5.6 release, and that was awesome. Because now those like basic containers are much more usable in Blueprint. But it'll be very, it's going to be very project specific. Right?
One quick thing. So obviously there's tons of benefits to the content creators or the people using these.
Yeah.
But that's primary here. Is there much cost to this? Does it take longer? Like, is the compile time affected, or is there a runtime anything? Is there?
No, not really. I mean, this kind of comes back to the optimization question. You can do a lot of bad stuff and make it look really simple, and then they get put everywhere, and so there's a little bit of maybe that, but like the Blueprint compile all happens offline, either locally when you're doing it or running it book. So like end users don't compile blueprints. Right. So you could produce a big complicated blueprint and it won't be a big deal. Ultimately, I don't think it's an issue. I don't think it's necessarily a big issue because well, it makes it easier to optimize because now you've got one thing you've got to fix, and it fixes all the uses of them. But at the same time, you don't. Where was I going with that? At the same time, you don't end up with these necessarily end up with these graphs that are way more complicated than they need to be, because you can if I go back to the dialog box one, now you've got these really nice execution pins on out of okay, they finished this, and you just kind of have you have a nice little flow of stuff that's very readable, as opposed to okay, I bind to this event, and now I have to go find this other function to figure out what we do from there. So I mean, it's a tool. It's a tool. There's trade-offs, as with kind of with anything else.
Sure. Bad behavior will still.
Bad behavior. Yeah, bad behavior is unsolvable beyond normal kind of review processes.
Right.
Great. Well, thanks, everybody.